Hi all, welcome to Sahara AS. Today we will be seeing part 3 of permutation and combination. So far we have studied how to arrange the letters in the words and how to arrange the letters in the words when the letters are repeated. Now we will be seeing some important concepts in the formulas of permutation and combination, the standard result. I have already given the factorial values, I guess. In last class or in part 1, I have given you the factorial values, that is till 10 factorial. Now we will be discussing, we have already discussed what is the factorial, that is n factorial is nothing but n into n minus 1 into n minus 2 etc. up to 3, 2 and 1. So this is what we have discussed. Now I can write, let's take an example first. 5 factorial, I can write it as 5 into 4 into 3 into 2 into 1. Now I can replace this 4 into 3 into 2 into 1 as 4 factorial, and I may get it as 5 into 4 factorial. So 5 factorial can be written as 5 into 4 factorial. Similarly, I can write any number n factorial. Any number n factorial can be written as n into n minus 1 into n minus 2 etc. up to 3 into 2 into 1. Now if I replace this n minus 1 into n minus 2 into etc. up to 3 into 2 into 1, this part can be replaced by n minus 1 factorial. N minus 1 factorial. So any number n factorial can be written as n into n minus 1 whole factorial. Similarly, if I consider same example like 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Now let me multiply and divide by 6. Now what happens? I can write this as 6 into 5 into 4 into 3 into 2 into 1 divided by 6. Now this numerator I can write this as 6 factorial divided by 6. So I can write 5 factorial is equal to 6 factorial divided by 6. Now if I want to generalize this, I can write this as n factorial. I can write it as n into n minus 1 into n minus 2 etc. up to 3 into 2 into 1. Now I will multiply by n plus 1 and again I will divide by n plus 1. So I can multiply and divide by any constant number, then I will still get the same answer. So I am here multiplying and dividing it by n plus 1. Then what happens? This can be rewritten as n plus 1 into n minus 1 into n minus 2 etc. up to 3 into 2 into 1 divided by n plus 1. Now the numerator can be written as n plus 1 whole factorial whole divided by n plus 1. So I can also write n factorial as n plus 1 whole factorial by n plus 1. So I have given you the two concepts here. One is any number n factorial can be written as n into n minus 1 factorial, and any number n factorial can be written as n plus 1 factorial by n plus 1. So two important concepts in permutation and combination, we should be knowing these two results. Then coming to the second result, as we have already discussed the formulas here for permutation and combination, NPR is equal to n factorial by n minus r factorial, whereas NCR is equal to n factorial by n minus r factorial into r factorial. Now if I observe n factorial divided by n minus r factorial, I can replace it by NPR. So I will get this as NCR is equal to NPR divided by r factorial. So this is the relationship between NCR and NPR. Maybe we have even discussed this in the last class. Now let me try to take some standard events like NP0. Let's check what happens for NP0. According to formula, NPR is equal to n factorial by n minus r factorial. If I consider NP0, then it will be n factorial by n minus 0 factorial. And n factorial by n minus 0 is again, n minus 0 is what? N minus 0 is n itself. So I can write this as n factorial. Now I can cancel n factorial and n factorial and I am left with 1. So I can take np0 value as 1. Similarly, if I consider ncr is equal to n factorial by n minus r factorial into r factorial. Now let me check what happens when nc is 0. nc0 is equal to n factorial by, in place of r I will be putting 0 as the value, n minus 0 whole factorial by 0 factorial, because r is 0 here. Now n factorial by n minus 0 whole factorial is again n factorial into 0 factorial. Now I can cancel n factorial. Anyhow 0 factorial value is already 1. We have studied this. So it is 1 divided by 1 into 1, which is simply equal to 1. So I can also say nc0 is also equal to 1. So these are the two standard results that we should be knowing in permutation and combination. Then moving further, let's check what happens for np1. np1, I can write this as n factorial divided by n minus, in place of r I will be writing 1, so n minus 1 factorial. Now as we see earlier that n factorial can be written as n into n minus 1 whole factorial divided by n minus 1 whole factorial. Now if I cancel n minus 1 factorial and n minus 1 factorial, I will be left with n. So np1 value will be equal to n. Fourth one, if I have nc1, then I will be having n factorial by n minus 1 factorial into r value is 1, so again 1 factorial. Now n factorial can be written as n into n minus 1 factorial divided by n minus 1 factorial into 1 factorial. Now I can cancel n minus 1 factorial and n minus 1 factorial. 1 factorial value is also equal to 1. So it is n by 1 and this will be anyhow 1. So answer is again n. So nc1 is also equal to n and np1 is also equal to n. These are the next two standard results that we should be knowing in permutation and combination. Moving further, let's see what happens when it is npn. Now I am taking the value of r is equal to value of n. Let's see what happens in this case. I can write this as n factorial divided by n minus, in place of r I will be writing n again, so n minus n factorial. N minus n factorial, I can write this as 0 factorial. We know that 0 factorial value is 1, so it can be written as directly n factorial. So npn value will be equal to n factorial. This is the next result. Next, coming to the last result, that is ncn. Now again in this condition, in combination condition, I am taking the value of r is equal to n. Now it can be written as n factorial divided by n minus r factorial, but instead of r I can replace this by n. So n minus n factorial into r factorial. Here r is equal to n, so I will again write this as n factorial. Hope everyone are getting this. I am replacing the value of r by n. Now I will get n factorial by n minus n factorial is 0 factorial into n factorial. Now if I cancel this, n factorial I can cancel. It is 1 divided by 0 factorial is again 1 into 1. 1 divided by 1 into 1, final answer is 1. So answer for NCN is 1. So I have given you 6 results, that is when r is equal to 0, r is equal to 1 and r is equal to n. If you observe here, when r is equal to n, n will be equal to n factorial and ncn will be equal to 1. You should be aware of all the 6 conditions that I discussed in today's class and also the property of factorial. After this, in combination and permutation, we should also remember these points. Is it possible to have n less than r? Let's take like 7p10. Is it possible to have this? So what is the meaning of 7p10? 7p10 simply means I am arranging 10 items out of given 7 items. So whenever I have only 7 items, how can I take or how can I arrange 10 out of 7 items? This is not possible. So I can't have n as less than r, or I can't have r is greater than n. R is greater than n possibility is not there in either permutation or combination. Suppose if I say I will give you 10 items and I will ask you to arrange 12 items. Is it at least possible? Can I arrange 12 items when I am giving you only 12 items, 10 items? When 10 items is given, I can't arrange 12 items, right? So it is not possible to have r value greater than n. One more condition, can I have r value equal to n? Suppose if I say 7p7, when 7 items are given, can I arrange all the 7 items? Yes, I can. So it is possible to have r value equal to n, and obviously r value can be less than n. If I am having 7 items and I need to arrange 3 items, 7p3 is possible, but first condition is not possible. So I can merge all these and I can say r cannot be equal to n, but r can be less than or equal to n. So you should be knowing this. Now I have shown it for permutation. It is the same condition holds good for combination as well. Even in combination, the only difference is that here I am arranging the elements, there I will be selecting the elements. So these are the next two important points you should be knowing. R cannot be greater than n and r is always less than or equal to n. Then coming to the last point, which is greater for any given values of n and r, for any given values of n and r, we should be knowing that npr value will always be greater than or equal to ncr value, because as we know, except when r is equal to 1, we have already seen this. See what happens when r is equal to 1. If we observe here, when r is equal to 1, here np1 and nc1, the value of np1 and nc1 will be equal. And in all the other cases, whenever it is greater, when r value is greater, then it will always, npr will always be greater than ncr. So I can generalize and say that npr is either greater than or equal to ncr, because the arrangement, number of arrangements of any items will always be obviously greater than or equal to number of selections. If I want to explain this, let's consider 3 items A, B, C. Now let me try to select 2 items out of 3 items. I can select AB, I can select BC, I can select AC. But if I want to arrange 2 items, then AB is one arrangement, BA is one arrangement, BC is one arrangement, CB is one arrangement, AC is one arrangement, CA is one arrangement. So if I consider NP, that is here n value is 3 and I am arranging 2 at a time. So if I consider 3P2, the answer will be 3 into 2, that is 6. But if I consider 3C2, then it will be 3 into 2 divided by 2 factorial, which is 2. So it will be 3. If you observe, these two are different arrangements, but they are same selection. Here also I have selected AB, here also I have selected AB, but I have arranged them in the different ways. So if I consider like this, these 3 are the different possible selections, and these 6 are the different possible arrangements. So in this way, I can say you that number of arrangements will always be greater than or equal to number of selection. Now let's take one condition where A, B, C. Now I need to select 1, 1, 1. I can select A, I can select B, I can select C. Now if I want to arrange 1, 1, 1, again I can arrange A, I can arrange B, I can arrange C. So whenever there is only one item that is to be selected or arranged, there is nothing called arrangement for one item, right? We are just selecting it. So in that case, what happens? Permutation will become equal to combination. That is, NP1 will be equal to NC1. This is possible only when R is equal to 1. When R is greater than 1, then we get NPR is greater than NCR. For this condition, NPR will be greater than NCR. Then in the all condition, like let's say when R is equal to 1, I will be having NP1 equal to NC1. So this is all for this classes. I have given you two separate properties of factorial. Then we have discussed 6 extreme conditions of permutation and combination. Then we have discussed the relationship between permutation combination, as well as we have discussed the inequality that is related to N and R values. So this is all for this class. Thank you.